this chemistry procedure, I'm going to be making nitric acid. And although that's not remarkable in itself, this may be different than other ones you've seen because I'm not going to be doing any distillation to get the nitric acid. I'll be synthesizing it directly from two chemicals, and the undesired one is insoluble, so it will precipitate out of solution, and it can be filtered out, leaving nitric acid. So I'll show you what the equation is for that. So here are the two chemicals that you will need. You're going to need calcium nitrate and sulfuric acid. Now, I did have a video that I made previously that showed how I made the calcium nitrate. So for every gram of calcium nitrate, you're going to need 0.5977 grams of sulfuric acid. Now remember, this is if it's 100% strength, which it won't be. So you have to divide the 0.5977 by whatever percentage your sulfuric acid strength is to get the amount you'll have to add. Now the products you're going to get is 0.768 grams of nitric acid and a precipitate of calcium sulfate of 0.830 grams. Now for this reaction to work without a lot of byproducts contaminating your acid, you're going to want to balance the amounts very carefully. And so I have my sulfuric acid here in this drain cleaner. The literature that I could find online about it says it's 93.2%, which is a very accurate number to have, but I've never verified that. I'll be trying to verify it. And the way I'll do that is I'll use this volumetric flask to measure its density. And online I found a table that shows the density versus percentage of nitric acid. So I'll measure the dry weight of the flask, then fill it up to the reference line with my sulfuric acid, then weigh the entire thing, and I can calculate the density, look it up on the table, and see what the strength is. So hopefully these numbers will be in close agreement. Now the calcium nitrate, which I made previously, also has to be carefully considered that it may have some water in it, so you want to get it as dry as you can. So I'm going to be putting it on the hot plate and heating it up, stirring it around to make sure it's absolutely dry before I weigh it. So that's what I'll do, and then we'll get on with the rest of the process. So 100 milliliters weighs 182.63 grams, which is a density of 1.826. Consulting the table, I get 1.82, so it's somewhere between 92 and 93%, almost 93, and it was supposedly 93.2, so that's very close. So I'll probably go with 93%. So it's been a couple of hours and I've stirred it a few times, and I've had the heat on all the time. So now I'm going to give it one final stir here. And if you have a watch glass, you can put it on top of the beaker like this. And if you don't see any steam forming, you can probably safely assume that it's dry. So I'm going to turn the heat off now. I'll let it set for about 5 minutes because I don't want to put the hot beaker directly onto my scale. So I'll let it cool down some and then I'll give it another weigh. So we lost about 0.56 grams from heating, so it was almost dry, but it was worth doing. But I still don't know the exact weight of the calcium nitrate because I don't know the weight of the beaker. So I'll have to solve that, but that shouldn't be very hard. So after having washed and thoroughly dried the beaker, I'll get a dry weight. 160.75. So I have 105.17 grams of calcium nitrate. So with that number, I can go ahead and calculate how much of the sulfuric acid I'm going to need. So as I showed earlier, this is the how to balance the ingredients to get the right amounts. So I just determined that I had 105.17 grams of calcium nitrate. So I multiplied that by 0.5977. That tells me I will need 62.86 grams of pure sulfuric acid. And I determined earlier that my concentration is actually 93%. So I divide by 0.93, which means I'm going to need 67.59 grams of my sulfuric acid when I do the reaction. So I'll carefully weigh out that amount. Here's one more calculation I forgot to do, so I now completed that. The expected amount of nitric acid is 80.77 grams, and I got that number by multiplying 0.768 by 105.17. And also, the calcium sulfate should be 87.29 grams of precipitate, which should be produced in the reaction. And there's the 67.59 grams of sulfuric acid. Alright, so at long last, I think I'm ready to do the main reaction here. So, first thing, I'm going to add some distilled water. Now, you have to make a trade-off here. The more water you add, the more dilute your final acid will be. But with less water, it's more difficult to filter out, so you have to compromise. So what I'm going to do is add enough water to get about 150 milliliters of total solution. I'm going to put in a stir bar, and with no heat, I'm just going to let that dissolve. eventually the stir bar will work. So that as it has dissolved, the level has dropped a little, so I'm going to bring that back up just a little bit. Well, it's all dissolved, but it's cloudy. I don't know why, but I'm going to proceed anyway. So I'm going to put a watch glass on top, and as I said before, this is a cool at room temperature, and I'm going to slowly add the sulfuric acid. It did get fairly hot. It's self-heating, so I'm going to cover this whole thing with some plastic wrap just to help contain any of the sulfur dioxide gas that may be produced. And I'll just let that set for a while, cool down, maybe stir it a little bit later. So after stirring several times and letting the whole thing set overnight, which was probably way longer than it needed to, this is what the result looks like. It looks like you might think it's impossible to filter anything out of that, but I think that's not true. So I'm going to give it a try. So the setup here is just a coffee filter with this vacuum filter flask and a little vacuum hose here. And it's not a strong vacuum, it's just this little tiny pump here, but it actually helps a lot, and it's very inexpensive. I bought it on Amazon. So after about quite a bit of time, I've only recovered 100 milliliters of liquid. I think I should have had more water in this, so I'm going to have another 100 milliliters of water here. I'm going to dump in and see if I can get that to extract more acid. So I'll turn the pump back on and give it a good stir. as I slowly add the Actually, I think I need to remove some of this. There's actually too much precipitate in there for this to work well, so I'm going to scoop some of it out. I just needed a bigger funnel. I don't know if I punctured the filter or some of it went over the side, but I'll filter it again. So I definitely tore the filter paper on this, so I'll have to be redoing this. So I'm set up and with the new filter and I'm ready to try this again. So first I'm going to put in the acid that I've already filtered that needs to go through again because of the bad filter paper. This should go in pretty smooth. So that looks like it came through nice and clean. So I'm going to save this bit and then try and filter out some more. So here we go again. This time I'll do it in smaller batches. So I think I got most of the liquid out of there. So I'll go ahead and, at least for now, try and save the sodium sulfate. And maybe I'll dry that out and save that too. Not that I really need it. It peels off nicely. Hopefully I get all of it in this time and I'll be done with this. So into this beaker I just put a lot of water to wash out the remaining calcium sulfate. And I'm going to dump that water into this dish just to help wash this all. I'm not going to go and show in the video how I wash and dry this. Basically, it's just several washing steps and then just drying it. So I'm sure if you want this, you can figure that out. So here's all the acid that I recovered. Volume-wise, it looks like about 225 milliliters. So it looks pretty clean, but now that I got it in this condition, I think I'll filter it one more time through a good high-quality lab-grade filter just to get it as clean as I can. So this is the Buchner funnel that I use. Just thought I'd show that to you. It has a bunch of little tiny holes in the bottom. And I'm going to use this grade 3 filter paper. I don't know exactly what grade 3 means. It's just better than grade 2 for filtering small particles. I'm going to moisten the paper a little bit just so I can get it to lay down flat. Now, I'll turn on the vacuum and pour in the acid. Okay, so it looks like roughly 250 milliliters. And the clarity is very good. Slight yellow discoloration is probably from nitrogen dioxide dissolved, or possibly something from the dye of the drain cleaner, but I think it's the former. So the next step is going to be determine the strength, and I'll do that by measuring its density, just like I did the sulfuric acid at the beginning. So here I have measured out exactly 100 milliliters of the nitric acid. And it weighs 115.13 grams. So that means a gravity of 1.15. And also, I'll check the temperature. 17.3 degrees Celsius. Now, consulting my table, it looks like about, there's 1.1503 at 15C. That's 25% nitric acid, according to this table.